With a new camera concept based on neutrons, the research team at the Technical University of Munich can take much sharper pictures of the inside of certain objects than with previous camera systems. Even in fossilized material, details become discernible, such as in fossils or metal.
Neutrons compared to X-rays provide a different contrast mechanism. We often use neutrons where X-rays don't provide enough penetration. So particularly if you have dense materials like metals, X-rays can only penetrate a few millimeters versus neutrons can penetrate several centimeters. And then in particular, if you want to have a good contrast between light and heavy elements, then you can also use neutrons because neutrons, for example, provide good contrast to hydrogen at the same time as providing a good contrast to iron.
So-called scintillators are installed in the device, which convert neutrons to light and make it usable for the camera. In all previous cameras, the light is collected during the entire exposure time. This results in blurring, depending on the thickness of the scintillator. The research team's new concept, on the other hand, can detect each individual light particle produced by a neutron. This makes it possible to filter out the noise in images.
So meaning that we can use thicker scintillators and regain a lot of the resolution that is lost, and therefore having a higher efficiency or shorter acquisition time for high-resolution images. And for X-ray imaging, this would mean essentially that we can have a lower dose to the patient, acquiring the same type quality image with essentially the same system, but in a shorter time, and with also more details, less noise, and so forth.
Medical imaging should also benefit from these advantages. In X-ray imaging of a bone fracture, fine structures, such as bone hairline fractures, would be more easily identifiable, while at the same time minimizing radiation exposure for the patient, because the exposure time would be reduced. The technology is also conceivable in radiotherapy. The prerequisite for being able to evaluate the very large volumes of image data in real time is new chip technology, as well as hardware and software with computing speeds. In order for the technology to be used, some components still have to be optimized for common imaging processes and cameras.
We are at an early stage of this development. Right now, this development is finding its place in research. That's just how it is with any other detector development. And currently, with this new development, obviously, one of the next steps is developing new scintillators that can be combined with this technology to use it more efficiently. So there is going to be a process where the scintillators will be refined, which will take some time. And then once you find a suitable scintillator for medical imaging, there's obviously also going to be the process of licensing and so forth. And for medical purposes, this is a pretty long process. So I envision this technology to find its place in medical imaging within the next 5 to 10 years.